This is part 3 of section 1.5. Let's graph this function by starting with something in our function library and making the necessary transformations. Now, this is not written in exactly the best form. This is the same as negative times the square root of x plus 1 squared plus 2. I've just rearranged this, and it fits our pattern a little bit better. So we have a reflection of some kind, a horizontal and a vertical shift, so we need to talk through those. I'm going to write down my plan, and then I'm going to go do the graph. So we deal with horizontal shifts first. So right inside here, I'm going to be going left 1. Okay. And then I deal with the reflection. It is outside, so it is an up-down flip, which means it's over the x-axis. And then finally, we deal with this. So we're going to go up 2. Now, again, I'm going to draw in some, what I tend to call ghost dots. I'm going to put in some points on our originals so that you can see how we're moving things around as we go along. So we're going to start off with x squared, which has 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and so on. That's enough for me to get the shape of my graph, which is mainly what I'm interested in. Okay, so now I'm going to use a different color real quick, just so you can sort of see the process here. So this was just x squared. Now I'm going to move these left 1. So I move every dot left 1. And I have that now. Okay. Now I'm going to reflect it over the x-axis. So 0, 0 stays the same, but this one flips over to here. This one flips here. It's 1 unit away from the x here. 4 units away here. So 4 here and 4 here. So now I have this graph once I've reflected it. And now finally, I take all of these points and I move them each up 2 units. You can see that some of these points were used several times, but your basic graph, doesn't have to be beautiful. It's going to look something like that. Okay, so let's write an equation for the function whose graph is the same as f of x equals x squared, but it's going to be shifted 2 units left and then reflected about the x-axis. Okay, so 2 units left means that I'm going to have x. Left means I'm going to have a plus 2 units, like that. And now I want to reflect it about the x-axis, so that's a vertical flip, which means the negative is going on the outside. So y is equal to negative times x plus 2 all squared is the answer we're looking for there. Okay, so we have shifted things around, we have flipped things, and all of those were rigid transformations because the basic shape of the graph is the same. Maybe it got flipped over, but it still has the same angles. Okay, now we need to talk about stretching and compressing. For reflections, we were multiplying by a negative 1. Okay, and if the number in front is anything other than 1 or negative 1, you're going to have some sort of stretching or compressing, whether it's vertically or horizontally. And this is a non-rigid transformation because we do change that. Notice again that the vertical is outside. Okay, the graph of g of x equal to a times f of x. So we have a multiplier here that is outside of our function. And the way we do this is we multiply the y-coordinate of every single point on the graph of our original by that number, and we don't change our x. Okay? So what ends up happening is if A is a number larger than 1, so imagine that we have x squared and it's normally like this, then it's going to be stretched away and get more like that, okay? A vertical compression, like this, so it's flattening it out. It would take it and make it go flatter, and I realize how far zoomed in I'm in here, and that's not working as well as it would in normal class, and I apologize for that. But if you're multiplying by a fraction, then it ends up being compressed and flattening out. So we're talking about the difference between a shape like this, a shape more like this, and a shape like this. Okay? So we deal with this. And then, if that number that in the multiplier is a negative, that means we're also going to have a reflection involved. We need to do the compression or stretching first, which is why if you look at the formal definition here, it has an absolute value in it. So basically we ignore the negative for a step, figure out how to compress things, and then we do the reflections that we need to take care of. Okay? Now, horizontal stretching and compressing is very similar, except the multiplier is inside. Okay? So the graph of g of x equal to f of b times x, we have a multiplier and it is inside of our function. The way we get that from our original graph is multiplying the x coordinate of each point on the graph by 1 over b and leave the y unchanged. Okay. And again, whether it is a stretch or a compression depends on whether the multiplier is between 0 and 1 or fraction, or if it's larger than 1. And again, if we have a negative involved, we stretch or compress first and then flip. So your final order, if you have multiple transformations, we first do the horizontal shift. Then we stretch or compress. Then we take care of the reflections, and then we do a vertical shift.